all brand new to you. It should feel very familiar to you, which is lovely. So this is the form of a quadratic, y equals ax squared plus bx plus c. Your a value can't be 0 because that takes the x squared out of the problem, and then it won't be a parabola anymore, right? If I put a 0 in right here, 0 times x squared is just 0, and then it would be a straight line instead. So this is a U-shaped curve, a parabola. It can open down as well, so it's not always a U in terms of pointing up, but it's that U-shaped curve. So like that, or like this, is a parabola, okay? And we talked about the parent function for a parabola being y equals x squared. So I graphed that for you here. Y equals x squared would look like this. Where's your vertex in that graph? 0, 0. The parent function, y equals x squared, always has a vertex at 0, 0, okay? Where's your axis of symmetry?
X equals 0.
X equals 0. What's another way to say the line x equals 0? What is this line right here called?
Y.
It's the y-axis, okay? So your axis of symmetry is the line x equals 0. Now recall, I was very picky that you always wrote x equals. I'm still very picky about that in this chapter, okay? It is an equation of a line, so you need to write it as the equation of a line. X equals 0 will be that equation, okay? Okay, now here's what I want you to think about. If this is my graph, right? If this is my U-shaped curve, I want to know what the domain and range for that U-shaped curve would be. So domain is what, x or y? Domain is your x values, okay? So basically I'm saying, what could my x be? What could I plug in for x here? Can you plug in a negative number? You can. Can you plug in 1,000,000? Can you find what 1,000,000 squared would be? Yeah. So your domain is all real numbers. And I wrote always because that never changes in parabolas. If we are working with a quadratic function, your domain will always be all real numbers. That should be a free point on every quiz or test because it never changes. It is all real numbers, okay, for a parabola. The range, however, does change. So the parent function has a specific range, but all the other ones that we do when they shift, it'll change a little bit. And that'll make sense as we go. I'll show you an example of that. But what would the range of the parent function be? What could so remember, this is domain is x's, your range is your y's. What are the possibilities for your y values in this graph? Can y be a negative number? It never drops below the x-axis, right? Its low point is the x-axis. So that means our y value is going to be greater than or equal to what number? 0, right? Greater than or equal to 0. Okay, so that's the range for the parent function. The range will change as we graph different parabolas, okay? But domain will never change for parabolas. Okay, so then vertex form gets a little bit fancier. So the parent was this, y equals x squared. But what if we shift to a new spot to start our parabola? Then it's going to look like this. Do you remember what this was for us? A shift. So minus something would be a shift to the right. Plus k would be up. That's assuming your h and k are positive values, right? So we shifted. This h and k represented our vertex, right? So our vertex is going to be whatever the h value is and whatever the k value is. Okay? So then if this is my vertex, my axis of symmetry, think about it. If I have a graph like this, okay, my axis of symmetry, does that relate to my x value or my y value? It's the x, right? The x value is never changing on that line. So our axis of symmetry is always x equals what, generally speaking here? 0. Not 0.
Oh.
It shifted. It shifted this way. However many you shifted is your h value, right? So your axis of symmetry is always x equals h. Okay, then with parabolas, you'll either have a maximum or you'll have a minimum. Let me show you what that means. So if I have a graph that looks like this, right? I have a minimum on that graph. I have a low point. I don't have a high point because you have arrows that just keep going. So that goes on forever. There is no end to those arrows. So I don't have a maximum, but I do have a minimum, right? Whereas if I have this graph, this is my maximum point, right? It's the high point of my graph. So if I flip it upside down, I have this high point, but I don't have a low point anymore because my arrows keep going, okay? Oh no, you took the test. You took the test. Did anyone else in here not take the test? I mean, other than the people I talked to? Okay, no, sorry, all of a sudden, what?
I don't think Noah was here.
He's not here again though, right?
No.
Yeah, okay. Okay, so for this one, max and min, basically what this works out to, if you look up here in our form, here's the A, right? What did we kind of treat A like? The slope. It's kind of like your slope. And you'll see today where it's not exactly like your slope, but it's kind of like your slope. I'll show you in a minute. So if that A value, if that value out in front is greater than 0, meaning if A is positive, okay, if your A value is positive, what way is your parabola opening when this number is positive? Does it open up or down? It opens up. So if it's opening up, do you have a maximum or a minimum? A minimum. So if your A is greater than 0, you have a minimum at your vertex Y coordinate. So whatever your vertex was, your minimum is the Y value. Okay, and this will all make sense once we start laying it out with actual numbers. That means if your A value is less than 0, so if your A value is negative, then you're going to have a maximum in the problem, and it will be your Y coordinate again. All right, then also related to your A's, if your A is a number greater than 1, so not a fraction, right? Well, not a fraction between 0 and 1. If your A number is greater than 1, we call it a stretch, meaning it gets real narrow and it stretches up or it stretches down, okay? So it kind of closes in. We call that a stretch. If it's a fraction between 0 and 1, we call it a compression. And what happens is it kind of, if you push down on it, right, it compresses, it opens wider then. Okay, so a stretch is going to get narrower, compression gets wider. Okay, so there's two ways that we're going to do graphs for this stuff. Sometimes we're going to make a table, and sometimes we're just going to use the idea of a shift that we used in the previous chapters to say like, oh, well, I know this one just shifts down 3 rather than have to plot all the points for it, okay? But for this first set, we're going to just do the table of values so you can see like, here's one way you could always graph something, okay? So it says make a table of values. Table of values is your t-chart, right? You have an x value and a y value. We're going to do 5 points, and it's always going to be the same 5 points because it just keeps it consistent, okay? So we are going to do -2, -1, 0, 1, and 2. All right, so if this is my table of values, then I'm saying f of -2 is if I go 1/2, parentheses matter, times -2 squared. All right, I'm just plugging in that x value right here. What's -2 squared? A +4, okay? So you can just plug this into your calculator exactly how you see it, and you'll get the right answer. if you use parentheses. If you don't use parentheses, you're going to get the wrong answer every time, okay? So be careful with parentheses. If we do this, we plug it in, 4 and then cut it in half would be 2. Okay, this would be half of negative 1 squared, parentheses matter. What do you get? 1 half. I'm just going to write it as 0.5. You may write it as 1/2. That's fine too. If you plug in 0, half of 0 squared is 0. Okay, plug in 1, half of 1 squared is 1/2, and half of 2 squared is 2. Okay, so you can always graph a parabola by plugging in points. I'll show you in a minute why it's not always the best method, because when it shifts to different places, plugging in -2, -1, 0, 1, and 2 doesn't always get you what you're hoping it gets you. So if we graph this, -2, 2, -1, 1/2, 0, 0, 1, 1/2, 2, 2. You get this parabola. Jessica, what's up?
So you multiply 1/2 and then in the parentheses squared, and then you half it to get 2 or like to get your y.
So I'm multiplying by 1/2 at the end because PEMDAS says I have to do the exponent first, right? So I'm taking -2 squared is 4, and 1/2 times 4 is 2. Okay? Questions on that? Okay. Just to clarify something real fast, because this is where this number, right? This is our A value. A lot of times people see that and they go, oh, my slope is 1/2. Now look at this graph. If I did a slope of 1/2, that's up 1 over 2, which lands me there, which is not right, okay? When we take our A value as a slope, you still have to treat it as that number over 1, okay? So if you're gonna look at this as a slope, we went up 1/2 over 1, and that's what put us there. So just a heads up on that. That's why when I say it's kind of like a slope, it feels a little different like that, right? 1/2 over 1 is how you would treat it as your slope more. And you can only do that for one thing on each side of your vertex, okay? But you don't need to worry about that quite yet. I'm just so you see. Okay, look at the next one. First of all, can you tell me how this parabola is going to open? Down. Okay, and now think about the number. This was a fraction, so it got a little bit wider. This is -3. It's going to narrow, right? We call that a stretch. It's going to get narrow. It's going to stretch up. So keep that in mind. When you see this, it should give you an idea of what your graph is going to look like, okay? So make your T-chart, X and Y, and we're going to go -2, -1, 0, 1, and 2. So this is -3 times -2 squared. What do you get?
12.
-12. Okay. Then you do -3 times -1 squared. So -1 squared is 1 times -3 is a -3. -3 times 0 squared is 0. Plug in your 1, you'll get a -3. Plug in your 2, you'll get a -12. Okay. I'm going to count by 3s here on my grids. So 3, 6, 9, 12, just so it lays out a little bit nicer. So when we plot these, -2, I'm going to count by 3s this way too, just so you can see the stretch that's going on. So -2, -12, 3, 6, 9, 12 is going to be like right here if we're counting by 3s. -1, -3 is right there. 0, 0 is there. Reflected. Okay, so look at your graph. It got real narrow. Okay. Questions on that? And again, this is like a slope of -3/1. So we went down 3 to the right one and down 3 to the left one is essentially what happened there. Okay, these ones are a little bit nicer, a little less work, I would say. Now we're going to do the graphs, but we're going to shift instead of put all the points into the t-chart, okay? And you guys know how these shifts work because you've done it for me. So it should be helpful. And then we'll only have to plug one thing into our t-chart. So if this is our setup, okay, tell me where x squared minus 5 is going to shift. Up, down, left, or right? Down 5, right? When it's minus 5 outside of the x squared, we're going down 5. Okay, so down 5. 1, 2, 3, 4, 5 is our starting point. What is our a value right now? A is 1, so that means we can essentially do one slope. So up 1 over 1, up 1 over 1 in both directions, one time, okay? Not multiple times, then we'll get a V. We don't want a V, we want a U. So you can go up 1 over 1 and up 1 over 1 to get your next 2 points. I want to see the general shape of my curve, so I want one more point and then we'll reflect that one more point. So let's say if we're talking X and Y, can anyone tell me a good number to plug in for X, seeing what we have on our graph so far? 2 would be great, okay? Do you see why 2 is great? We already have 0 for our X value. We have 1 for our X value, so the next best one is 2. So if I plug in 2 for X, I'm saying 2 squared minus 5. Okay, so 4 minus 5 is a -1. So I'm going to plot one more point at 2, -1. And then we have this line of reflection, right? Our axis of symmetry. So where is another point going to land if we reflect that point? -2, -1. You don't need to plug that in. You can just reflect it from this guy, right? Just drop him over on the other side. So here's your axis of symmetry, and here's your graph. Okay. Can you tell me the domain of this graph? Always. Remember, the domain didn't change. What? All real numbers. The domain is all real numbers. Okay, now stop and think about the range. Your y values, right? Range is y, would have to be what? Less than or equal to or greater than or equal to some number. They're going up, right? So they have to be greater than or equal to. And then you look at your vertex. What is your y value at your vertex? -5, right? We went down 5. So y has to be greater than or equal to -5. So that's your domain and range with your graph. Lots going on there, right? Okay, take a look at this one and then I'll have you try C on your own. Where are we shifting for a +1 inside the parentheses squared? We're going left 1 unit, right? So if I shift 1 left, I'm here. What's your A value? A is 1. Okay, that means you may do one shift of a slope of 1. Okay, so we're going to go up 1 over 1 to the right, up 1 over 1 to the left. So what is a good number? God bless you. What's a good number to plug in for X? You could do 2. There's a better one. We did -1. We did 0. 1 would be the next best one to plug in. So if I plug in 1 for my x, then I get my f of x equals 1 plus 1 squared. What is that? 4. 2 squared is 4. So this is another point on my graph, 1, 4. Okay? So let's plot 1, 4. 1 to the right, 1, 2, 3, 4 up. What do I do with that? I need one more point. Reflect it, right? So here's my axis of symmetry. That's where my vertex is. If I'm 2 to the right of my axis of symmetry right now, my new point needs to go 2 to the left of my axis of symmetry, and here's my graph. Okay, what is the domain of that graph? All real numbers, free points, right? Always all real numbers. What's the range of that graph? What are the options for your y values? Y is going to be greater than or equal to what value? What's your lowest y value? What's your minimum? 0, right? This is your low point right here. That's where y is equal to 0. So y has to be greater than or equal to 0. How are we doing on that? Okay, you try C. Notice there's 2 shifts for C. There's one that goes left or right, and there's one that goes up or down. See if you can figure out what to do with that. See what you did here. So looks like most of you got your shift down. So this is to the right 2. This is up 1. So to the right 2, up 1 puts you here. What's your A value? A is 1, right? There's nothing out in front there, so we assume A is 1. So that means you can go up 1 over 1 and up 1 over 1. Okay. What's a good number to plug in here? So 4 is great. Is there a better one? 0. 0 is such a lovely number to work with. So you could plug in 0 or you could plug in 4 because we want to be outside of the 3 points we already have. So I'm going to plug in 0. You don't have to. You can plug in 4 if you want. So if I plug in 0 for my x, that's 0 minus 2 squared plus 1. So negative 2 squared is 4 plus 1 is 5. So 0, 1, 2, 3, 4, 5 puts me here. Notice here's your axis of symmetry. So if I just reflect that over my axis of symmetry, I'm going to end up right here. And then that will be your graph. Good on that? Okay, tell me how this one's going to be different. It's a negative. So what's it going to do? It's going to open down. Okay. So where does this one shift, first of all? Up, down, left, or right? Up. So we're going to go up 1.5. That's going to put me here. Okay. Now you got to be a little bit careful here because your A value is -1. So if we're treating that like our first slope for a first move, we're going down 1 over 1, right? But we're at a halfway point. So make sure you go down 1 over 1 and stay at that halfway point. You need to move 1 unit down, okay? Okay, so we're there. What's a good number to plug in for your x value here? 2 is great, right? We did 0, we did 1, now let's do 2. So if I plug in a 2, I get, what do I get? Be careful here. Does that negative, this negative, does that go inside or outside parentheses? Outside. So this is the opposite of 2 squared plus 1.5. Okay, so we square this. 2 squared is 4. So this is -4 plus 1.5, which is what? negative 2.5. So this is the point we're going to plot. So 2, negative 2.5 would be here. Here's your axis of symmetry. We're going to flip that over the axis of symmetry. So we were 2 to the right. We're going to go 2 to the left. And this is our graph. Okay, what's the domain of that graph? All real numbers. You can plug anything in for x. What's the range of that graph? Be careful, this one's a little different. Y is less than or equal to. What's your y value right there? 1.5, 1.5. Okay, it's always the y value that we use our range with. So look at where your y high point is. Y will be less than or equal to that. Okay, last two. These are the real fancy ones. I'm going to give you all the things, and you have to give me all of the things. So the vertex, the axis of symmetry, graph it, find the minimum, find the domain, find the range, and then we're going to find the y-intercept too. And I'll see if you can figure out how we're going to do that. So look at this equation. We said your vertex is always HK. What is that right now? That is a positive 4 and a negative 2. Remember, it's the opposite of what it looks like inside. It's the same as what it looks like outside. Okay, so 4, negative 2 is your vertex. Can I just tell you how important it is that you get the right vertex? It is so important that you get the right vertex. If you mess up on the vertex, you mess up on everything. Okay, so take your time when you're finding your vertex, because that is the most important piece of it all. Thank you, ma'am. Okay, so if 4, negative 2 is my vertex, thank you, then my axis of symmetry is what? It's not 4. It's what? X equals 4. Your axis of symmetry is always x equals your h value. Okay, see why the vertex is very important? You get h wrong, you get your axis of symmetry wrong too. So my vertex is 4, negative 2. So let's plot that. 1, 2, 3, 4, negative 2 would put us right here. Axis of symmetry, plot that too. Can you tell me your next 2 points, or what you're going to do to plot them? What? You don't need to make a t-chart yet. What value up here have we not used yet? The 3. What does that 3 do for us? Treat it like a slope one time, right? So where are we moving? Up 3, 1, 2, 3 to the right one, and up 3 to the left one. And this should be narrow, right? Because it's a 3, not a fraction. So it is narrow here. Then it says, oh, you know what? I don't make you do another one for this. I'll just let you graph it with these two. You could plug in a number. If you were going to plug in a number, what would be a good one? 2 would be great. I'm not going to make you do it on this one because it is going to be a big number. But you could plug in a 2 right here to find another point. Typically, I'll only make you do 3 points on most of these. If it says, give me 5 points, then plug in another number, okay? What's your minimum here? Negative 2, okay? And I don't make you write that as a vertex because you have your vertex already. So your minimum can just be what your y value is. So your minimum is negative 2, right? We don't ever go below negative 2 on our y value. What's your domain? All real numbers every time. Your range is always going to use this minimum number, okay? So y has to be, is it greater than or equal to or less than or equal to? If it's on its way up, it's greater than or equal to, and then that minimum number. Okay, last thing, how do you find a y-intercept? You find a y-intercept for something. John.
Did I plug in 0?
Yeah, if we plug in 0 for x, we will always get a y-intercept. Okay, so that's what we're going to do. We're going to plug that in. We're going to take this equation. I'm going to say y equals 3 times 0 minus 4 squared minus 2. That's 3 times negative 4 squared is 16 minus 2, and 3 times 16 minus 2 is 46. So our y-intercept is the point 0, 46. We don't want to graph that, right? That's huge. Questions on that? Okay, you try number 4, and then we're done. All right, tell me what you got for your vertex. Opposite of what's inside, the same as what's outside, right? This should be opposite, this should be the same. So negative 3, 4. What's your axis of symmetry then? Not negative 3. X equals negative 3, right? Make sure you put the x equals. I will mark it off if you don't give me the x equals because it's a line. So negative 3, 4 is here. Here's your axis of symmetry. Okay, make sure you graph that. Where are your next 2 points going to go? What are you going to do with that? What's that negative 2 doing for you? That's your slope. So down 2 to the right one and down 2 to the left one. Okay, and then I'm just going to graph that as we see it right now. So what is your maximum? It's your y value, right? So that's a positive 4. Maximum is 4. What's your domain? Oh, good job. You guys got that. What's your range? Less than or equal to whatever your maximum number was, right? Y is less than or equal to 4. And then how do you find your y-intercept? Plug in 0. So y equals negative 2 times 0 plus 3 squared plus 4. So you get negative 2 times 3 squared is 9 plus 4. So y equals negative 18 plus 4 is a negative 14. So your y-intercept is the point 0, negative 14. And that is it. Okay, so familiar, right? Like you've seen a lot of